Hello everyone. Today we are looking at a problem from GATE DA 2025 paper. The problem is given as we have x which is said to be normally distributed with variance sigma square and mean mu. We have two transformations. One is z is equal to x minus mu by sigma, and the other transformation is y equals to z square. So the question asks to find the variance of y, and there we can see that few options are given. We have to find the exact value of variance of y. So in order to solve this problem, let's first write down what is the distribution of x. So as we know that from the given question, x follows normal mu sigma square distribution. So what will be the PDF of x? The PDF of x will be fx of x equal to 1 by root over 2 pi sigma e to the power minus half x minus mu by sigma, where the range of x will be from minus infinity to plus infinity. Now what do we have? We have z equals to x minus mu by sigma. First of all, let's find what is the range of z. The range of z is minus infinity to plus infinity. Why? Because we can see from the transformation, as x moves from x moves towards minus infinity, we can see that the value of z becomes minus infinity, and as x moves towards plus infinity, the value of z almost becomes plus infinity. So the range of z is from minus infinity to plus infinity. And now we can write this transformation in form of real variable. So in real variable, we have z is equal to x minus mu by sigma. Then dz dx, which is the derivative of z with respect to x, is basically 1 by sigma. And since sigma square is the variance, so sigma is the standard deviation, and standard deviation is always positive. So this value should be greater than 0 for all x belong to minus infinity to plus infinity. Thus we can easily say that z is a monotonic function, and in case of monotonic function, the distribution of the transformed variable, that is here in this case the distribution of z is given as fz of z is equal to mod dx dz fx of, instead of x we substitute sigma z plus mu. Why? Since z is equal to x minus mu by sigma, so from here we can write x is equal to sigma z plus mu. Now just after substituting this value, we get sigma into 1 by root over 2 pi sigma e to the power minus half. In place of x we are going to write sigma z plus mu minus mu divided by sigma, this whole square. And since we have seen that what is the range of z, the range of z is from minus infinity to plus infinity. So after just a little bit of simplification, we will find that if z of z is nothing but 1 by root over 2 pi e to the power minus half z square, where the value of z lies between minus infinity to plus infinity. This particular distribution is has a special name. So we say that z follows standard normal with mean as 0 and variance as 1. So this is standard normal distribution. Thus we can say that if x follows mu sigma distribution, normal mu sigma distribution, then z follows normal 0 1 distribution. This is called standard normal. Now there is a second transformation. The second transformation is given as y is equal to z square. From here we can also determine what will be the range of y. The range of y will be from strict 0 to infinity, because y is square of something, so it can never be negative. It can have the lowest value of 0, otherwise its value will always increase. So the range of y will be from 0 to infinity, and in terms of real variable, we get small y is equal to z square. Now if we differentiate y with respect to z, we are going to get 2z. Now we know that the range of z is from minus infinity to plus infinity. So this value can become greater than 0 if z is greater than 0, and this value can become less than 0 if z is less than 0. In other words, y is not a monotonic function, so we cannot apply standard transformation formula here. So in order to solve this kind of distribution problems, to solve this problem, we use the method of CDF, or cumulative distribution function. CDF, or cumulative distribution function. So what will be the CDF of y? We have Fy of y, which is nothing but probability that capital Y random variable takes value less equal to small y. This can be written as probability z square less equal to small y, which is equal to minus root over y less equal to z less equal to root y. And in terms of CDF, we can write it as capital Fz of root over y minus Fz of minus root y. So what will be the density function of y? Now density function of y will be Fy of y, which is nothing but the differentiation of the cumulative distribution function, that is f dash y of y, which is equal to differentiation of this given value, that is, what is the differentiation of capital F Fz of root y? It will be f dash z root y, and by chain rule we are going to differentiate root y, that will be 1 by 2 root y, minus what will be the differentiation of fz minus root y? This will be minus 1 by 2 root y into f dash z minus root y. Now what is f dash z? It is nothing but the density function of z, which is fz of root y into 1 by 2 root y plus 1 by 2 root y fz of minus root y. Now just substitute these values. We are going to take 1 by 2 root y as common. We are going to get fz root y my plus fz of minus root y. This is equal to 1 by 2 root y, and fz of root y is nothing but 1 by root over 2 pi e to the power minus y by 2, and fz of minus root y is also same because the square of minus root y will be y only. So this is also 1 by root over 2 pi e to the power minus y by 2. Now just adding them, we are going to get 1 by root y e to the power minus y by 2 divided by root over 2 pi, provided the range of y is y strictly greater equal to 0. Now the our problem now is solved. We have find out the distribution of y. So let's let's modify it a little bit more. We can write it as e to the power minus y by 2 y root 1 by root over y can be written as y to the power half minus 1 divided by root 2 can be written as 2 to the power half, and root pi can be written as gamma half. Now I am making a claim. The claim is, if I have a random variable x which follow chi-square distribution with k degrees of freedom, then the distribution of x is nothing but e to the power minus x by 2 x to the power k by 2 minus 1 divided by 2 to the power k by 2 into gamma k by 2. This is the distribution of chi-square with k degrees of freedom. So from the given form we can easily say that our random variable y is basically chi-square 1 following chi-square 1 distribution. And in case of chi-square distribution, the variance of y is nothing but 2 into degree of freedom, and here since the degree of freedom is 1, so we can write 2 into 1, we are getting the value as 2. So for our given problem the variance of y is actually 2. I hope this video is understandable, and since here I have used few concepts like what is the transformation formula, you can easily find these formulas in any kind of standard probability textbooks. So I hope this sum is understandable. So if there is any kind of problem, feel free to contact me. So with that I am ending this video. Thank you.